We are going to go over the Mixed Practice Chapter 8. The first 8 problems say to determine if the sequence is arithmetic, geometric, or neither, and write a rule for the sequence. So let's first talk about the difference between arithmetic. They have a common difference, and the pattern is adding. And sometimes it looks like subtracting, but we're always talking about what we're adding. So if it's subtracting, we're adding the negative. The geometric has a common ratio, which looks like repeated multiplication or division, but we always talk about it in what we're multiplying. So if it's division, we talk about what we are, the fraction that we're multiplying by. Neither doesn't fit into either of those categories. So if we look at number 1, 2, 4, 6, 8, the pattern is plus 2, plus 2, plus 2. So we have a common difference of 2, which makes it arithmetic. And our equation is an equals a1 plus n minus 1 times d. This is our arithmetic. And our geometric equation is a1 plus times r to the n minus 1 power. So to do number 1, an equals a1, which is 2, plus n minus 1. When we write the rule, n is a variable and d is 2. So 2 plus 2n minus 2. You have to distribute and simplify. An equals 2n for number 1. Number 2, 2, 4, 8, 16. The pattern is times 2, right? Times 2. So r is 2. It's geometric. And it's an equals 2, my a1, times r, which is 2, to the n minus 1 power. There's no simplifying to do here. I've seen students multiply the 2's together to make a base of 4. That we cannot do because order of operations says exponents have to come before we can multiply, and the exponent's a variable, so we can't do that before we multiply, and we can't distribute a base to the exponent. So this is the rule. We don't do anything with it. Number 3, 3, 8, 13. It looks like plus 5 to me. So D is 5. And so that's arithmetic, or arithmetic, however you want to say it. I get an equals a1 plus n minus 1 times 5, which is 3 times 5n minus 5. So an equals 5n minus 2. Now number 4, 1, 4, 9, 16. I'm not adding the same thing every time. It's plus 3, plus 5, plus 7. Can't multiply by the same thing, but these are perfect squares. So this is neither. And our equation is n squared. 1 squared is 1, 2 squared is 4, 3 squared is 3, 4 squared is 16. Number 5, 5 halves, 5 fourths. Looks like we're multiplying by 1 half, and that's geometric. So an equals 5, my a1, times 1 half to the n minus 1. Again, that cannot be simplified like the arithmetic equation, so we just leave it. Number 6, 100, 50, 25. Looks like it's times 1 half. Remember that we want to think about it in what we're multiplying, not what we're dividing. So if we see division by 2, that's multiplying by 1 half. If we see dividing by 3, multiplying by 1/3. And if we can't figure it out, D is a2 minus a1, and r is a2 divided by a1. So you can always do that calculation if you don't see the pattern first off. So again, number 6 is geometric, and an is 100 times 1 half to the n minus 1. Number 7 is plus 3, plus 5, plus 7. That looks a lot like number 4. And if you look at the relationship between the two, 1 plus 1 is 2, 4 plus 1 is 5, 9 plus 1 is 10. So we get a pattern of n squared, whatever we had in number 4, just one more than that, so plus 1, and this one's neither. And 8 is 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 5 is 8, 5 plus 8 would be 13. This is the Fibonacci sequence, and so this is also neither. You don't have to write the rule for this. But if you were, it'd be a n minus 2 plus a n minus 1. So this term, a3, is a2 plus a1. a3 is a3 plus a4. You can really only write this in a recursive formula, and that's the kind of formula you're looking at there. That would be a minus. The next set asks us to find the sum of the series. We're going to have to determine which type of series it is and then make that decision. Remember that our arithmetic series is Sn equals n over 2 times a1 plus an. And a lot of times we have to use the an equals a1 plus n minus 1 times d equation to find the information that we need. Our geometric equations are an is a1 r to the n minus 1. We don't have to use that as much because our sum equations adapt. Sn equals a1, 1 minus r to the n. That exponent is inside the parentheses over 1 minus r. Or Sn equals a1 minus an times r over 1 minus r. Don't forget the 1 minus r in the denominator. And then our infinite geometric is S equals a1 over 1 minus r, only if the absolute value of r is less than 1. So r has to be between -1 and +1. If it's greater than 1 or less than -1, there is no sum. If the absolute value of r is greater than 1 or equal to 1, there is no sum. All right, so let's look at number 9. 3, 6, 9. It looks like I'm adding 3, right? So my a1 is 3, my an is 33, and my d is 3. We're adding 3 every time. So I don't know n, and my arithmetic sequence or series formula requires me to know n, so I have to plug it in. 33 equals a1 times, plus n minus 1 times 3. 33 equals 3 plus 3n minus 3, and 33 equals 3n. Divide by 3, and your n is equal to 11. So your sum of 11 terms is going to be 11 over 2 times 3 plus 33, which is 11 over 2 times 36. Let me change this color. 2 goes into 36 18 times, and 18 times 11, 180 plus 18, 198. Number 10, what's my pattern? So you have to first determine whether it's arithmetic or geometric or infinite. It's got an ending point of 729. And my pattern looks like times 3, times 3, times 3. That looks good. So number 10 is going to be geometric. And I have an, so I'm going to use the second formula. The sum of the terms is equal to a1, which is 1, minus 729, my an, times 3, over 1 minus my r, which is 3. So S equals 1 minus. Do not forget your order of operations here. You have to multiply before you can subtract. So I get 1 minus 2187 over -2. And 1 minus 2187 is negative 2186. Divided by -2. And we get 1093 is my sum. Number 11, this dot, dot, dot means going on forever, so that means infinite. So I need to determine whether my r is less than 1 or not. It's getting smaller, and 6 over 12 is 1/2. So my r is 1/2, which qualifies for less than or equal to, or less than 1. The absolute value is less than 1. So I can use my infinite formula. My a1 is 12. So 12 over 1 minus r, which is 1/2. And 12 divided by 1/2 is 12 times the reciprocal, 2 over 1, 24. Number 12. I have a1 equals 4, n equals 6, and d equals -3. Which type of formula has d in it? Not the geometric, it's arithmetic. So I have a1, I have n, but I don't have an. So I'm going to need to find an by using my an formula that has d in it, the arithmetic formula. So an equals 4 plus 6 minus 1 times -3. That's 4 plus 5 times -3. 4 minus 15 is -11. Now I can use my sum formula, sum of n terms n over 2, a1 plus an. So for the arithmetic, I need to usually use both formulas to find everything that I need. Sn is a 6 over 2 times a1 is 4 plus -11. 6 over 2 is 3. Don't forget to just divide if it divides in evenly and make your life easier. I see some of you trying to solve things like this, 6 over 2, and you're multiplying by 2 and then dividing by 6 instead of just making it 3. 4 plus -11 is -7, and 3 times -7 is -21. Number 13 says a1 equals 4, n equals 6, but r equals -3. So pretty much the same information at 12, but giving us an r means it's geometric. So we're going to use our sum of n terms is a1, 1 minus r to the n over 1 minus r. And so that's the sum of 6 terms is a1, which is 4, 1 minus -3 to the 6 over 1 minus -3. Remember order of operations, -3 to the 6th has to happen first. And so that's a positive 729 divided by positive 4. The 4's cancel, and we get -728, the sum for 6. And then number 14 says we have a1 equal to 5, we have n equal to infinity, and r equals 1/3. If r is the absolute value of r, 1/3 is less than 1, yes, I have a sum. If r was 3, there would be no sum. So my sum formula, a1 over 1 minus r. So that's 5 over 1 minus 1/3, which is 5 over 2/3. 5 times 3 over 2 is 15 over 2. Okay, remember that we want your answers in fractions. Number 15, we're looking at summation notation now. We are going to look at the equation, 3n plus 4. That's a linear type equation. There's no exponents, so this is arithmetic. Which means I need to find my a1 and my an by plugging the bottom in to find a1. So that's 3 times 2 plus 4. Plug the top in to find an. Oh, that's 6 plus 4 equals 10. The top is 9, so 3 times 9 plus 4, 27 plus 4 equals 31. So my a1 is 10, my an is 31. Now my n for the formula is not this n equals 2, it's how many numbers from 2 to 9. So if you count on your fingers, or we do n is equal to 9 minus 2 plus 1, which is 7 plus 1, 8. So n is 8. So 8 over 2 times 10 plus 31. That's 4 times 41, which is 164. Number 16, our formula has an exponent. The variable is the exponent. That makes it geometric. So we're going to plug in the bottom to find A1. I recommend always plugging in the bottom number, whatever it tells you, n equals in the bottom of the summation, the sigma, and plugging it in to find your A1. 3 times 1/2 squared is 3 times 1/4, which is 3/4. And my n equals 10 minus 2 plus 1, which is 8 plus 1, 9. And my r is always the base of the power, so 1/2. And then I plug it in, A1, the sum, is A1, 1 minus r to the n over 1 minus r, which is going to be 3/4 times 1 minus 1/2 to the 9th over 1 minus 1/2, 1 minus r. So that gives me 3/4 times 1 minus 1 over 5/12 over 1/2. Now I'm dividing by 1/2, which means I can multiply by the reciprocal. So I can put that in the top here and say this is 2 over 1, multiplying by the reciprocal, times the 3/4, and 1 minus 5/12. 1 is 512 over 512. If I subtract 1 512th, I get 511 512ths. And the only thing that's really going to simplify here is 2 goes into 4 twice. So I end up doing 3 times 511, which is 1533. And then 2 times 512 over 1024. Keep your answers in fractions. Work with your cross multiplying. Remember what we did in chapter 7. Diagonally, you can divide things out. So divide out common factors diagonally to make your multiplication smaller so that you ensure your fractions are reduced. Number 17, the summation from 1 to infinity. Okay, there's a big red flag. Check for r. R in this case is 5. 5 is greater than 1, so there is no sum. Okay, make sure you check that. You cannot have a sum if the geometric series keeps getting larger. Number 18, 3 times 5 to the I minus 1 from 1 to 4. This is geometric. My n is from 1 to 4, which is 4. My r is 5, and let's plug in 1. We get 3 times 5 to the 1 minus 1, which is 3 times 5 to the 0. 5 to the 0 is 1, and so my A1 equals 3. Just to make sure that I'm getting the right numbers. So the sum is A1, 3, 1 minus 5 to the 4th over 1 minus 5. I like this formula usually because it doesn't require me to plug in the top to find an. I especially like this with fractions. It's going to make, I think it makes the fractions easier to deal with because it's that 1 minus the fraction, which is an easier common denominator issue. So we get 3 times 1 minus 5 to the 4th is 625 over negative 4. And that's 3 times negative 624 over negative 4. 624 divided by 4 is 156. And 156 times 3 is 468. The negatives cancel, so I get a positive 468. Number 19. This is a linear type equation. There's no exponents. We're looking at arithmetic. So from our n is 15 minus 6 plus 1 which is 9 plus 1, 10. So n is 10. And my a1, I get from plugging in 6, negative 3 times 6 plus 1. Negative 18 plus 1 is negative 17. an, I'm going to plug in 15. Negative 3 times 15 plus 1 is negative 45 plus 1, which is negative 44. And then I use my formula, n over 2. 10 over 2 times negative 17 plus negative 44. That's 5. This is actually s of 10 terms. Negative 17 plus 44 plus negative 44 is 61. And 5 times 60 is 300, so 305. And because that's a negative 61, it's negative 305. So really be careful about your negative signs. And lastly on this page, number 20. There's that infinity on the top. So the first thing I'm going to do is to identify r as 1/4. 1/4 is less than 1. The absolute value is less than 1. Remember that the sign doesn't really matter. And so I can find the sum. So a1, 12 over 1 minus 1/4, which is 12 over 1 minus 1/4 is 3/4. And 12 times the reciprocal, 4 over 3. 3 goes into 12 4 times. 4 times 4 is 16. All right, number 21, write the rule given the following information. Our two rules, arithmetic, an, a1 plus n minus 1 times d, geometric, an, a1, r to the n minus 1. So if it's giving me r, I'm using the geometric, so a1 is 2, r is 2/3, that's the geometric. An equals 2 times 2/3 to the n minus 1. And number 22 gives me a1 and d, so I just plug it all in. 1 because it's giving me d. An equals a1, negative 21, plus n minus 1 times 4. Remember when I'm writing the rule, n and an are my variables. And for arithmetic, I need to distribute and simplify. I cannot leave it like this. So that's negative 21 plus 4n minus 4. So negative 25 plus 4n, or 4n minus 25. Either way is okay. Number 23, also arithmetic. An equals a1 plus n minus 1 times negative 5. That becomes 6 plus negative 5n plus 5. Remember to distribute the negative, so I get negative 5n plus 11, or 11 minus 5n. And number 24, my a1 and my r, it's giving me r, so I'm plugging it into the geometric equation. An equals a1 1/2 times negative 7, my r to the n minus 1. And find the indicated variable. So we're going to have to use a combination of the equations, possibly some systems, to find the indicated variable here. Find a1 if n is 20, d is 3.5, and s20 is 1005. So it's giving us d. That means it's arithmetic. If it doesn't give you r or d, or ask for r or d, it has to tell you whether it's geometric or arithmetic. So for number 25, I need to find a1. Well, what do I know? I know the sum. I know that the sum, n over 2, a1 plus an. I know n is 20, and I know the sum is 1005, 20 over 2 times a1 plus an. But I don't know a1, and I don't know an. So 1005 equals 10 times a1 plus an. So let's see what we can get out of our other equation. An equals a1 plus n minus 1, so 20 minus 1, times d, it tells us, is 3.5. So we get a n equals a1 plus 19 times 3.5. A n equals a1 plus 66.5. 3.5 times 19, just to make sure. Now, I can take this and I can plug it in here. This problem will be on your test. It was on the quiz. It's going to be on your test. So make sure you know how to do this problem. Okay, so Sn, obviously different numbers, but 1,005 equals 10 times, oh, I can plug it into the simplified formula, a1 plus 66.5, and that's 10 times 2a1. It's just a1 plus a1, like x plus x is 2x. a1 plus a1 is 2a1 equals 1,005. I'm going to divide by 10, and I get 100.5 equals 2a1 plus 66.5. And then I'm going to subtract 66.5, and we get 34 equals 2a1, divide by 2, and a1 equals 17. Okay, so you have to use a system of equations on some of these that ask you to find the missing variable. Number 6 asks for d. So again, we're looking at arithmetic. I know a1, I know an, I know a sum. So we plug in what we know so far. 26. The sum is 2247. That equals n over 2, I don't know n, 17 plus 197. Well, I have everything but n in this equation, so I can find n, and then I can probably use that in the other formula to find d. So let's see, 2247 equals n over 2 is 214. 2 goes into 214. Because it's even, I'm just going to do that division, is 107. 2247 divided by 107 is 21. So that's 2247 equals 107n, divide by 107, and n is 21. So now I didn't find what I needed to find. It asked me to find d, so I need to use a n equals a1 plus n minus 1 times d. A n is 197 equals 17 plus 21 minus 1 times d. That's negative minus 17, so 180 equals 20d. Divide by 20, and we get d equals 9. Okay, let's look at 27. It says that Sn is 315. It tells me R is 0.5, n equals 6. Find A1. Okay, it's giving me R. That means I'm geometric. We're going to use our Sn equals A1, 1 minus r to the n, over 1 minus r equation. So Sn is 315 equals A1, what I'm trying to find, 1 minus 0.5 to the 6th over 1 minus 0.5. So 315 equals A1 times 1 minus 0.5 to the 6th equals, okay, it's a long decimal. And if you don't use the whole decimal, you are going to get the wrong answer. So if you would rather do it in fractions, change the 0.5 to 1/2. If not, you have to leave the entire decimal, okay, so that you get the right answer. Now I'm going to multiply both sides by the 0.5 to get rid of the denominator. Remember that cancels and then does not cancel and distribute. It just cancels. So 315 divided by 2 or times 0.5 is 157.5 equals A1 times 1 minus point, oh wait, let's do the 1 minus point, 0.15625, and that's 0.984375, and 157.5 divided by that, oops, 157.5 divided by the 0.984375. Don't get lazy and round, otherwise you're not going to get the right exact answer. So A1 equals 160. All right, let's look at number 28. 28 says SN is 249.92. R is 0.2. N is 5. Find A3. In order to find A3, I got to know A1. So let's see. I have R and N and S of N. If it's R, it's geometric. So we're back to that same equation we used on number 27. Sum is A1, 1 minus R to the N over 1 minus R. So 249.92 is equal to A1. That's what we need to know in order to find A3. And 1 minus 0.2 to the fifth over 1 minus 0.2. So 249.92 equals A1 times 1 minus 0.2 to the fifth is 0.00032. Again, don't start rounding, and you may have gotten 3.2 e to the negative 4 in a calculator, or times 10 to the negative 4. And remember, that moves the decimal place 1, 2, 3, 4 times, and that puts in 3 leading zeros. 1 minus 0.2 is 0.8. And so 1 minus 0.00032 is 249.92 equals A1 times 0.99968 over 0.8. We're going to multiply both sides by the 0.8 to cancel it. And 249.92 times 0.8 is 199.936 is 0.99968 times A1 divided by 0.99968. So 199.936 divided by 0.99968. I get 200. So A1 equals 200. So how do I find A3? We multiply by R, so times 0.2. That's 40. That's A2. Times 0.2 is 8. So A3 equals 8. Number 29 says that the sum of an infinite number of terms is 81. R is 2/3. Find A1. So it's infinite, so it's the S equals A1 over 1 minus R formula. So 81 equals A1 over 1 minus 2/3. 81 equals A1 over 1/3. We're going to times by 1/3 to eliminate the denominator. And A1 equals 81 times 1/3, which is 27. And lastly, number 30, sum of an infinite number of terms is negative 13 and 1/3. And A1 is negative 8. Find R. So I have to make a mixed number improper. 3 times 13 is 39 plus 1. Remember, that's how we make our mixed numbers improper. So that's 39 plus 1, negative 40 over 3. I don't incorporate the negative sign when I'm doing that. The answer is just negative. That's going to equal negative 8 divided by 1 minus R. And we are going to multiply both sides by 1 minus R. And we get we're going to leave it. Negative 40 thirds times 1 minus r equals negative 8. And we're going to multiply by the reciprocal to get rid of that fraction. And we're going to cross cancel 40 and 8. 8 goes into 8 once, and 8 goes into 40 5 times. So 1 minus r, because those cancel, equals negative, and negative is positive 3/5. And then if 1 minus r, subtract your 1, negative r is equal to negative 2/5. Remember that 1 is 5/5, and 3/5 minus 5/5 is negative 2/5, so r is positive 2/5.